Hello dear student, today we will study the progressive cavity pump, that is called PCP. It is an important artificial lift method under secondary recovery technique. So progressive cavity pump is a kind of positive displacement pump. It has two components. First is rotor, that is typically made with metal with hard chrome coating, and it has different number of lobes, and it is the moving part of the progressive cavity pump. The outer body is called stator, and it is generally made with elastomeric material like rubber. It has the number of lobes, generally one more than the rotor, and it is kept stationary during the operation. We can see the diagram. The rotor is rotating inside the stator and its center continuously changes. So eccentric motion takes place, and during the motion the fluid is trapped in the cavities between the rotor and stator, and the pressure is generated during the motion, which acts as a driving force for the movement of fluid in forward direction or positive direction in the positive displacement pump. The theoretical displacement or capacity of the progressive cavity pump is given by the product of area and stator pitch length, and that is equal to 4 into eccentricity E to rotor diameter D and the stator pitch length P. The theoretical displacement is represented in meter cube per day per 100 rpm or barrels per day per 100 rpm. The eccentricity is the difference between the pitch of the rotor and stator. In the lower diagram we can see that there are different number of cavities, various number of cavities. In these cavities the fluid trapped between the rotor and stator body, and the pressure is generated. The progressive cavity pump flow rate. The fluid leakage across the rotor and stator seal lines between the cavities result in actual flow rates that are lower than the theoretical flow rate. The volumetric efficiency of the progressive cavity pump is given by the ratio of actual flow rate to the theoretical flow rate. Progressive cavity pump pressure rating. The PC pump cavity pressure rating reflects the maximum recommended differential pressure across the rotor and stator seal. The typical value is between 65 to 75. The PCP system designs normally target a 50 to 80% pressure loading. Generally, the PCP pumps are not designed as per API product specification like sucker rods and sucker rod pumps, because the design, rating and nomenclature of the PCP pumps depends upon the market, and the supplier has flexibility as per the requirements. The PCP specification process such as elastomer fluid compatibility testing, pump testing and sizing were not consistent across the industry. So it may vary from industry to industry. Now the advantages of progressive cavity pump. So it has high system energy efficiency, that is 55% to 70%. It can also handle the highly viscous fluids. So for heavy fluids we can use the PCP pumps. It also has ability to produce highly viscous fluid up to 1 lakh centipoise. Its geometry can be designed to offer maximum flow area and low fluid velocity. So it also minimizes the emulsion formation. Another advantages are excellent resistance to particulate matter. So intermittent pumping of up to 60% sand in the liquid. So it can handle sand. Rotor rolling motion gently presses particle into the stator elastomer and releases particle back into flow. A rotor wiping motion does not trap the sand. So PCP has the capability to handle the sand. So it is an important method for the secondary recovery. So thanks for today. In my next lecture we will see another methods of artificial lift. Thank you.